Assalamualaikum warahmatullahi wabarakatuh. We are members from Group 19. Now we are going to demonstrate about Ohm's law.
Ohm's law describes mathematically how voltage, current, and resistance in a circuit are related. Ohm's law states that the current through a conductor between 2 points is directly proportional to the potential difference of voltage across the 2 points and inversely proportional to the resistance between them provided the temperature remain constant. The equation of Ohm's law is I equal V over R. V is the potential difference measured across the resistance in units of volts. I is the current through the resistance in units of amperes, and R is the resistance of the conductor in units of ohm. From the equation I equal V over R, we can know that when the voltage increase, the current will also increase this because current is directly proportional to V, while when the resistance decreases, the current will increase since current is inversely proportional to the resistance.
Now I will show how to measure current in a series circuit. First we need to change the multimeter to ampere. Okay, the reading is 1.80 milliampere. Next, I will show how to measure the 3 resistor. We need to change to resistance. The first resistor reading is 1.00 kilo ohm. The second one is 2.30 kilo ohm. The third one is 1.70 kilo ohm.
As you can see, I'm showing you a series circuit. So now I want to demonstrate how to measure the voltage across each resistor in this series circuit. To measure the voltage across this resistor, I call R1. First, we use the multimeter, set the mode to the voltage. Positive connect to the positive terminal, negative connect to the negative terminal. Start simulation, we get 1.8 volt. To measure the voltage across R2 and R3, we use the same method as R1. Start simulation, you will get voltage across R2 is 4.14 volt, voltage across R3 is 3.06 volt.
Now I'm showing you a parallel circuit. So I want to demonstrate how measure resistance and voltage across each resistor in the parallel circuit. For measure the resistor, we need to disconnect the resistor with the power supply. For R1, we take and we put here, and same method for R2, we put here. Okay, so I'm start the simulation. For R1, we get 500 ohm, and for R2, we get 1k ohm. Next, I'm going to show how to measure the voltage across R1 and R2. The voltage across the resistor in parallel circuit would be the same. And we start the simulation, and we get 8.96 volt for each resistor.
Now I'm going to show you how to measure the resistance across R1 and R2 in parallel circuit. To measure the current across R1, we need to take out the first leg of resistor 1. Then we start the simulation, and for the value of current across resistor 1, we get 17.9 milliampere. Then to measure the current across resistor 2, we use the same method as to measure the current across resistor 1. We need to check out the one of the leg of resistor 2 to measure the current. Okay, with that simulation and the current for resistor R2, we get 8.96 milliampere. That is the end of the assignment 4 for group 19. Thank you.